How heavy is Sledge's hammer? It looks like a 20-pound hammer, but just look at how much drywall it takes down. That can't be a normal hammer. But to those who say it's Sledge who's just so strong, he just keeps trucking through this drywall, look at what happens when he swings his hammer. As soon as he hits the wall, his hammer stops, just right there. This means that all the kinetic energy that is in the hammer is lost as soon as it hits the wall. So, if you find out how much energy it takes to destroy all that wall, we can find out how strong Sledge's hammer is. It may sound crazy, but we can do it. In this formula, KE stands for kinetic energy, and that is how much energy is in the hammer. The M is the mass of the hammer. That is what we're looking for. V, that's the velocity of the hammer. We're going to find all these things. So, how much energy is in the hammer? This article says that pine wood takes about 4,800 joules of energy to break. Pine is the stuff that's used in construction, which is what Sledge destroys. It's used in construction because it loves to bend, which makes it so much stronger for long-term stress. Sledge breaks a maximum of 3 boards with a swing, so multiply that by 3, that's 14,400 joules of energy. And by the way, for those of you that don't know, joule is just a measurement of energy. Now we just need to know how fast that hammer is going. So, let's take a look at his swing. It looks like his swing takes about 0.2 seconds. Now, I really need you to hold on for a quick second. Math is about to get kind of weird. Just a little mild. This is the same as, but for rotation. All these formulas are just common formulas that you'd see if you just took a high school level physics class. Haven't done physics yet? I really recommend it. You'll take a look, you'll see these formulas, but just know that the rotation ones that we're using, just a rotational version of the standard. See that big R? The big R is for rotation. That fish looking thing, that is angular acceleration. It's like acceleration, but for spinning things. And of course T is time. So we're looking for fish, so we're going to rearrange the formula using some basic algebra. The hammer rotates 90 degrees, which is 1/2 pi in radians. Radians is like degrees, but just a different form of measurement. Sort of how like you got inches and you got centimeters. There's no way showing it. So, after we do all the math, this will turn out to be 79 rotations a second. By the way, using the little A and the little arrow to represent the fish. With that information, we can do the same thing to find its final rotational speed. See that little swirly W? That's rotational speed. Much like velocity, but just the rate of things spinning. Alright, now that we have its rotational, we need to find it in its tangential form. But, oh no! How big is that hammer? Well, some simple pixel measurements. The ratio between Sledge and his hammer is 3.5 to 1.5, or his hammer to Sledge, 1.5 to 3.5. Sledge is 1.9 meters, so a simple ratio. And we find out that it's about 1.814 meters. After doing all the math, we can get its tangential velocity. Just plug in our numbers, and then plug in. Alright, let's go down. Think you guys got the drill? We just rearrange for mass, and we get 176 kilograms. But, for those of you in America, 388 pounds. Sledge himself weighs 230, and he is sprinting with this thing and casually swings it like 30 times a match. It just keeps on going. He just lays down, gets up, just burpees, whatever. This thing is so heavy. His back should be broken like a 90-year-old grandpa that has been in construction for the past 140 years. Alright, so we assume some things for this video. We assume that when Sledge swings his hammer, he swings it in a straight line. And for those of you who may have noticed, when Sledge hits the center of the drywall, the radius just disappears, probably a shockwave. Realistically, that's probably just for gameplay to make it simpler. Imagine if you had to actually swing through, get the right angle. That would just be terrible. Alright, so first long form video. Tell me how it went. I'd really like some feedback. I could keep going. I got a lot of stuff that, I've seen Matt Pat get wrong, and, his friend Austin. I'd really like to go over it. What are some ideas you have? I really need some ideas, because this is my last straw. I don't know, maybe I could talk about, like, breach charges. How powerful are they? I don't know, it's kind of boring. Talk about repelling. Talk about, ooh, you just feeling like a pendulum. But I really need some help.